Welcome to the Data Services virtual tour. We would like to describe our services and invite you to reach out with your research data related needs. First, let me introduce our team. I'm Jennifer Moore, Head of Data Services. I've been at WashU since 2011 in multiple roles. My expertise is in data literacy, management, sharing and curation, 3D data, data visualization, and GIS. I have degrees in anthropology, visual art, and library and information science. Dr. Doris Scott is social science data curator and GIS librarian. She's been at WashU since 2018. Her expertise is in data literacy, management, sharing, and curation, data analysis in R and GIS. Doris has degrees in international relations and affairs and geography. Molly Webb is the data and GIS developer and has been with WashU since 2015. Her expertise is in Python, automation, data wrangling, data analysis, and GIS. Molly has degrees in business and geography. Bill Winston is our GIS and data visualization analyst. He's a WashU alumnus and has worked in GIS here since 2008. He holds degrees in biology and earth and planetary science. Our team has a diverse set of skills, talents, and is always happy to assist you during our help desk hours or by appointment. We have 6 core services, which we will describe in more depth soon. They include data analysis, data sharing and curation, data literacy, data management, data visualization, and geographic information systems, or GIS. We help researchers take raw or messy data and shape it into something digestible and easy to understand. This is the research data lifecycle. You may have seen other versions, some more basic and others more complicated. This one highlights the various stages of research with the qualification that it may not be a perfect cycle. We understand that your work can hover in one stage and iterate back and forth between stages. What we want to describe in this presentation is how we can help you throughout this cycle. There are a couple of stages where we might not be as useful, like the idea stage or the inference stage, but we provide workshops, consultations, and even assistance at the other stages. I'll start by describing our data sharing and curation service. As you're likely aware, there is an increased pressure from funders, publishers, and research communities to share data because it increases the transparency of the research, encourages scientific advancement, and facilitates data persistence. Though sharing is encouraged, expected, and often required, not all researchers are comfortable with it. Research from a 2018 white paper published in Springer Nature found that the most common concern researchers had was that their data wasn't in a form that would be useful to others. In fact, sharing data without review or documentation is not that useful. And the reason that is can be clearly understood by referencing the FAIR principles. The FAIR principles were developed by researchers to describe the basic needs for useful data sharing. The data must be findable with descriptive metadata in an established indexed repository and have a persistent identifier. It must be accessible, meaning that the repository uses open standards and protocols. The data has documentation, which is maintained long-term. Interoperable data are in a formal, standard, open format, which does not require proprietary software as much as possible. Reusable means the data has robust documentation, including formats, provenance, licensing, variables, methods, etc. So an educated person can reasonably reuse it. Not every repository is as fair as another, though sharing at all is a great first step. But minimally, the repository should be indexed, provide descriptive metadata in a standard format like Dublin Core or DataCite. The repository should have backups and a recovery plan. Still, the data is not truly findable if the repository doesn't provide a persistent identifier. To ensure that the data is truly accessible, interoperable, and reusable, The repository might include some form of curatorial review, ideally by a domain-specific curator who can help researchers enhance their metadata and ensure the data is standard and open. Data services support your sharing and curation activities through providing that dataset review, metadata augmentation, and transformation to open formats. We can also help you identify the right repository for you in the case that the institutional repository isn't the one you need. We help to make sure your data is fair by evaluating it against the FAIR principles. And we provide a DOI when we ingest into our data repository so that your data can always be found and cited. I'll now pass the baton to my colleague, Dr. Doris Scott, to talk about data literacy.
Data services also provide support for data literacy. Data literacy is the ability to be able to find, evaluate, understand, and analyze data in a way in which you not only make convincing arguments with good data, but you're also able to assess the arguments of others in terms of the data they use and the conclusions they are making with the data. Finally, it is important for one to understand the data life cycle in terms of data being used from the beginning to an end of the project. Data literacy provides a foundation for data discovery, use, and reuse. There are some on the surface and under the surface considerations you have to think of when it comes to finding and using data. First of all, what is the data source? Is it from an authoritative source, such as a government entity, or is it from a random website? Is that so-called authoritative source have data reporting issues? Don't think of this process of validating the data source as one in which you are aiming to invalidate the data. However, it is important to understand that all data are not made equal. Another thing you need to think about are if the values you are dealing with are absolute or proportional values. This can make a big difference in how you interpret the data. For example, if you give a survey on whether people like Coca-Cola or Pepsi, 100 people who responded Coca-Cola in a town of 500 will take more weight than, say, 100 people who responded Coca-Cola in a town of 1,000 people. Not all absolute numbers are created equal, so proportional values might be more appropriate numbers to use. That being said, proportional values can be misleading too for the same reason. A 50% increase in a quantity of something when the original number was small is not the same 50% in a quantity of something when the original number is big. In the Coke example, in a town of 10, if only one person likes Coca-Cola in 2019 and 2 people like Coca-Cola in 2020, that is technically a 50% increase. However, the number only increased by 1 person. One final on the surface consideration is the margin of error. For example, in a given population, if the number of people who like Pepsi is 46% and the number of people who like Coca-Cola is 54%, and there is an 8% margin of error, then that means the range of people who like Pepsi can be anywhere between 46% and 54%. And the range of people who like Coca-Cola can range from 54% to 62%. Since there is a lot of overlap, you can't definitely say that people do like Pepsi more than Coca-Cola. Data services provide support in these 4 aspects of data literacy. Data services has a data literacy research guide, which provides information about the data lifecycle, data-related terms, and considerations when using data. In addition, we provide training in a variety of data-related tools such as R and R Studio, OpenRefine, and Python. If you need more individual assistance, feel free to contact us for a consultation. In addition, we can create a tailored workshop based on your group's needs.
Here are 2 recommended resources you can use for data management. WashU has an institutional license for the DMP tool, which has boilerplate data management plans, which you can customize for your use. There are various grant-based boilerplate templates available as well. Another recommended resource is the book Data Management for Researchers by Kristen Brenney, which is essentially a primer on data management.
We provide various types of support when it comes to data management in terms of establishing best practices, critically assessing data, data management tools, and collaborative platforms. We provide assistance on DMP tool and will also take a look at your data plan and give recommendations. In addition, we also have an institutional license for Open Science Framework and Lab Archives. Open Science Framework, also known as OSF, which is a free open source web application built to help researchers manage their workflows. Lab Archives is a cloud-based research data collaboration and management tool. It makes organizing, storing, and sharing lab data fast, simple, and accessible on all digital platforms. We provide individual assistance on these platforms through consultations, and we also have training opportunities in which we invite representatives from OSF and Lab Archives to give workshops on these tools. If you are looking to deepen your knowledge on data management, we also have Managing Your Data Research Guide, OSF Data Dictionary Guides, and workshops on data management and data sharing.
The next core service we are going to discuss is data analysis. We typically look at analysis as falling under one of two categories, quantitative and qualitative. Quantitative analysis involves measurements and phenomena that can be counted. Qualitative typically refers to text, ideas, or observations that require a level of interpretation as part of the analysis process. Historically, our collective expertise has leaned towards the quantitative, but we are actively working on bolstering our abilities in the qualitative analysis. Data analysis can often be broken down into subtasks, which can include data collection and cleaning prior to the actual analysis steps. One tool that our team has quite a bit of experience in is R&R Studio, shown here, which is an excellent tool for data cleaning, analysis, and visualization. R&R Studio are open source, which means that they are freely available for download and installation, and they are also cross-platform, meaning that they can run on pretty much any type of common operating system. Other tools for support of researchers' data analysis are included on this slide, including tools for systematic review and meta-analysis, which is assessing the results of previous research to derive conclusions about overall trends. We also have experience with REDCap, Qualtrics, NVivo, Python, SPSS, and the other applications listed here, which are all great tools for data collection, asking questions of the data, and making inferences based on the results of these queries. Once you've collected and cleaned your data, you may wish to start making visualizations as part of the analysis process or to present your final results after analysis, which brings me to our next core service, which is data visualization. Data visualization is essentially telling a story with your data. Visualization methods help researchers, of course, display their data, but also to examine variability, discover relationships, and communicate findings as part of the research lifecycle. Tabular and hierarchical data can be presented using information graphics like charts or graphs, and spatial data is traditionally shared as maps or graphic figures. An interesting, less traditional example of a dynamic data visualization is The Stages of Relationships by Nathan Yao, as presented on the blog Flowing Data. In this viz, Dr. Yao took data from a 2017 Stanford survey entitled How Couples Meet and Stay Together. Dr. Yao processed the data using R and created this viz using D3, which stands for Data-Driven Documents, and is a JavaScript library for data visualization. The viz compares the data from couples who met in the 1970s versus the 2010s and starts with their first meeting. Then, as the number of months and years increases, it shows many couples move through the stages of romantic relationship, living together, and married. What's interesting and perhaps intuitive is that more couples in the 1970s move faster to the married category, while the 2010s couples linger longer in the romantic and living together categories. I invite you to check this out when you get a chance at flowingdata.com. Our team is also well-versed in a variety of tools related to data visualization, such as the previously mentioned R&R Studio, as well as Tableau and SPSS, and the other applications listed on this screen. Our process usually begins with a consultation to learn more about your project. While we may not fully understand the specifics of your research, we can help you with tasks like organizing and cleaning your data, working with various tools, and assessing the effectiveness of existing visualizations. Next, I'm going to pass the baton to my colleague Bill to talk about GIS.
Thank you. And now let me get to our final core service, GIS. Geographic Information Systems, or GIS, refers to tools and spatial data that enable map creation and spatial analysis. Researchers use GIS to compile and overlay existing spatial data, create new data sets based on GPS measurements, digitize features from existing maps, join tabular information with spatial objects such as zip codes or county boundaries, and to perform spatial analyses, including identifying features within a distance or proximity analysis, routing from point to point, which is called network analysis, find areas where key factors intersect or overlay analysis, and selecting the best location based on multiple spatial factors, also known as site suitability. And there are many others. GIS integrates spatial thinking and relationships to allow place to become part of your research, and may even apply to projects that don't immediately seem to have a spatial component. Consider the example of how we refer to a generic soft drink. Some might call it Coke, pop, or soda, or use some other term. If we were to ask people to tell us what term they use for this beverage, we could compile a list with the frequency of each response, and that might be mildly informative. However, if we were also to ask for each person's zip code, which is a spatial identifier, we could incorporate place into our analysis and produce a map of the responses like this one from popversussoda.com. So this map shows zip code boundaries along with the color-coded term reported by respondents from that area. There may be many reasons for this linguistic variation, but we would never have recognized that there was an interesting regional distribution without placing the responses into a spatial context. This example illustrates that the simple act of creating a map can reveal hidden patterns, prompt further questions, and in some cases suggest answers. Coke is the predominant response in the Southeast, and Coca-Cola corporate headquarters are located in Atlanta, Georgia. Perhaps this begins to explain the regional preference for that term. Data services provide support for finding and evaluating data, understanding spatial problems, and for accessing and using GIS tools. Our services include the GIS Research Guide, where we compile information and help users find resources, individual support through our regular help desk and one-on-one consultations, training through standalone workshops and custom class-based lectures. Access to GIS software tools and data is available in the Research Studio in Olin Library. We also manage and distribute ArcGIS software licenses for use in labs and personal computers. Finally, we administer the WashU ArcGIS online organization, including web mapping and story maps. Please reach out to us if you need any of these services. We are happy to help. Now I'll send it back to Jennifer to wrap things up.
Data services have 3 tiers of service. At the first tier, it includes consultation through our help desk, use of our research guides, and we also provide generalized assistance that does not exceed 10 hours of service. At tier 2, users enjoy all the tier 1 support, plus customized materials and workshops, which don't exceed 10 hours, and consultation by appointment. Tier 3 includes tier 1 and 2, but is often characterized by the need for specialized consultation and assistance that exceeds 10 hours in a fiscal year. This tier requires application and evaluation before we can offer our services, and there may be cost recovery involved. Finally, please visit our webpage on the University Library site to get more information about our services, access our help desk, subscribe to our newsletter, or to contact our team. Thank you.